Okay, so let's continue with the next question, in which we have given a directrix x equals minus 9 by 5 with the given hyperbola 16x square minus 9y square equals to 144. So further we can convert this as 16x square by 144 minus 9y square by 144 equals 1. So it's x square by 9 minus y square by 16 equals to 1. So we have to find out the corresponding focus of this hyperbola. Now the thing is given that if I consider this as hyperbola, so this hyperbola has two types of directrix. This is first directrix and this is second. So if I consider this as 9 by 5 and this as minus 9 by 5, so corresponding to this directrix, this will be the focus, like A is 0, and corresponding to this will be the focus, right? So here we have given minus 9 by 5, so this will be the corresponding focus that we need to find out. Okay, so for that, from here we can get A equals 3 and B equals 4. As we know that equation of directrix is minus A by E equals to minus 9 by 5. So A has already answered 3, so 3 by E equals plus 9 by 5. So E will be 5 by 3. So therefore the focus will be, it's A0 minus A0, so it's minus 3 into 5 by 30, which is minus 50. So this will be the corresponding focus to this directrix. Okay. Next question. The locus of the center of the circles which touches the circle x square plus y square equals 1 externally and also touches the y-axis and lie in the first quadrant. We want to find out the locus of the center of the circle which touches this circle externally, which touches y-axis also, and that circle lies in the first quadrant. Okay, so let's first of all figure out these conditions. So first of all, if I want to plot a circle with x square plus y square equals 1 equation, so this is the circle having radius equals to 1 and center on at 0, 0. Now the circle whose center we need is touching this circle externally and y-axis in the first quadrant. So maybe it can be something like this, right? So this circle touches y-axis and this also touches this circle in the as externally, right? So if we have a condition, if you know that if a circle touches y-axis, then radius equals to x coordinate of center, right? So if I say that here is the radius and if I say that this can be the center hk, so we have radius equals to mod h. Okay, also if two circles touches externally, then we have a condition that if say this is center 1 and this is center 2, this has radius r1 and this has radius r2. So if two circles touches externally, then the condition is c1 c2 equals to r1 plus r2, that is distance between the center of two circles equals to the sum of their radius. Okay, so now let's follow the condition. So distance between two circles c1 c2 is 0 0 and hk is h minus 0 whole square plus y minus k whole square, k minus 0 whole square equals to r1. The radius of the first circle is 1 and the radius of second circle is plus h. So by doing square on both the sides, we get h square plus k square equals 1 plus h whole square. So h square plus k square equals 1 plus 2h plus h square. So k square equals 1 plus 2h. This will be the answer. So in general, if I want to write down, it will be y square equals 1 plus 2x. right? So this will formulate, this can be considered as a parabola also, right? But as far as the options are concerned, it is like y equals to root of 1 plus 2x for x greater than or equals to 0. This is from the option I can write down, right? Next question. Next question, we want to find out the negation of the statement. Let's say the statement P is negation S, disjunction, negation R, conjunction S. We want to find out negation of this Boolean expression. Negation of this Boolean expression. So negation P, so negation of negation X, disjunction, negation R, conjunction R. So as we all know, if we apply negation inside the disjunction, so negation of negation X, disjunction will become conjunction, and negation of negation R, conjunction S, according to the De Morgan's law, right? Now negation of any statement is equals to the statement itself, conjunction. Now here again we have to apply the De Morgan's law. That means negation of negation R, disjunction, negation S. So S conjunction R, disjunction, negation S. Now according to the distribution law, if S conjunction R, disjunction S conjunction negation S. So now if any statement and its negation with the conjunction, then it will be contradiction, right? So S conjunction R, disjunction, contradiction will give you answer as S conjunction R. So this will be your answer. Next question. If Z and W are complex numbers such that ZW equals to 1 and argument of Z minus argument of W is equals to pi by 2, then dash. 4 options given to us. Let me write down the options over here because we need to know the options first. So Z into W bar equals 1 minus I by root 2. B option has Z bar dot W equals to I. C option has Z dot W bar equals to minus 1 plus I by root 2. And in D option, we have Z bar dot W equals to I. Okay. So this is a kind of important question from complex numbers, right? Okay. So here there is given condition related with the argument. So let us assume that argument of Z as theta and argument of W as phi. Also the magnitude of Z, let's say R1, and magnitude of W, let's say R2. Okay, so how I can represent Z in terms of polar form? So Z can be represented as R1 e raised to I theta, and W can be represented as R2 e raised to I phi. Right, these two things we need to keep in our mind. Okay, so from this also, what will be the Z bar? Because Z is the complex number and Z bar is its conjugate. So conjugate can be represented as R1 e raised to minus I theta, and W bar will be R2 e raised to minus I phi. Okay, so now from these conditions we need to obtain a relation between ZW bar and Z bar and W. Okay, so if I multiply, or first of all from this given condition, argument of Z we have assumed as theta and argument of W we have assumed as phi equals pi by 2. So theta will be, it's phi plus pi by 2 we can say. Okay, now in Z replace theta with R1 e raised to I, theta with phi plus pi by 2. So it's R1 e raised to phi dot I pi by 2. This is the value of z we have, right? Because I need to check two things. I need to check z dot w bar and also z bar dot w. I need to check two things, right? So this is how we consider z as. Okay. Now if I multiply z dot w bar, so this is z r1 e raised to I phi e raised to I pi by 2 dot w bar as r2 e raised to minus I phi. So now it is already given that mode of z bar, z into w equals to 1. So this can be written as mode of z into mode of w equals 1, and we have already assumed that mode of z as r1 and mode of z w as r2. So from this we have obtained a result that r1 dot r2 equals 1. So you just check r1 dot r2 equals 1, e raised to I phi and e raised to minus I phi, that is to 1. So z dot w bar equals to what? E raised to I pi by 2, and e raised to I pi by 2 can be written as what? Cos pi by 2 plus I sin pi by 2. So z dot w bar equals, we have I only. Z dot w bar equals to I only, right? But according to the, here the option is minus I, sorry. Okay, but if you check in options, z dot w bar in both the options never equals to I, right? So these two options are not the answers. So now let's talk about z bar dot w. Okay, so in z bar, if I replace r1 dot e raised to minus I theta as phi plus pi by 2, and then now if I check for z bar dot w, so z bar is r1 e raised to minus I phi dot e raised to minus I pi by 2, and w as r2 e raised to I phi. So again r1 dot r2 equals to 1, e raised to minus I phi plus I phi again 1. So z bar dot w is e raised to minus I pi by 2, which is cos minus pi by 2 plus I sin minus pi by 2. Hence z bar dot w equals to minus I. This is your answer. Okay, in last question we have given that tangent and normal to the ellipse 3x square plus 5y square equals to 32 at point 22 meets x-axis at point Q and R. Then the area of triangle PQR we want to find out. Area of triangle PQR we want to find out. This is the point P. Okay. So let me figure out this. If I say this will be 32 by 3 plus y square by 32 by 5 equals to 1, right? So if we have an ellipse like this, and here then some point is 2 2. So at this point, at point 2 2, if I plot a tangent, if I plot a normal, so tangent will cut the x-axis at point Q and normal will cut the x-axis at point R. And if this is the point P, so we want to find out this area of triangle PQR. Okay, this point P is given as 2 2. So first of all, we have an equation of tangent of an ellipse, that any point x1 y1 on the ellipse, the equation of tangent is xx1 by a square plus y by 1 by b square equals to 1, right? So from this equation, it's 2x by 32 by 3 plus 2y by 32 by 5 equals to 1. So it's 3x plus 5y equals to 16. This will be the equation of tangent, right? And intersection of this tangent with x-axis is at Q. So it will be 16 by 30. Now from this, let us obtain the equation of normal. So equation of a normal will be 5x minus 3y equals to k. So at 2 2 it's 5 into 2 minus 3 into 2 equals k. So 10 minus 6 equals k, therefore k equals 4. So equation of normal will be 5x minus 3y equals 4. This will be the equation of normal. So this normal will intersect x-axis at r. So r has coordinate 4 by 5 0. So here is the point 4 by 5 0. And now we want to find out the area of triangle PQR, right? So area will be half mode of determinant. It's 2 2 1, 4 by 5 0 1 and 16 by 3 0 1. Right? So let us find out the area. So it will be half with mode. Let us expand from the third column. So second column. So minus 2 into 4 by 5 minus 16 by 3. Okay. So 2 to cancel. It's mode of 20 minus 80 by 15. So it's 12 minus 80, so it's minus 68 by 15. So area will be plus 68 by 15. Right? So this will be your answer. Okay.